This video will review the Georgia Standards of Excellence 3 OA 5, which states that students will apply properties of operations as strategies to multiply and divide. Students will understand that when using the commutative property of multiplication, that if 6 times 4 equals 24 is known, then 4 times 6 equals 24 is also known. Students will also develop an understanding of the associative property of multiplication. 3 times 5 times 2 can be found by grouping 3 times 5 to get 15, and then multiplying 15 times 2 to get 30. Students can also change the grouping to multiply 5 times 2 first to get 10, and then 3 times 10 equals 30. As students use their knowledge of the commutative property to change the order of the factors, the groupings can be modified to make multiplying easier. Lastly, students will apply the distributive property of multiplication by knowing that if they know 8 times 5 equals 40 and 8 times 2 equals 16, one can then find 8 times 7 as 8 times 5 plus 2, which equals 8 times 5 plus 8 times 2, or 40 plus 16 equals 56. Students progressing from first and second grades will have been exposed to both the associative and commutative properties when adding, but third graders begin to apply properties in multiplication situations. While it is not important that students memorize the names of each property, they do need to apply each strategy. When exposing students to the properties of multiplication, it is important to provide repeated experiences with concrete and semi-concrete arrays. The link to this digital program can be located below the video. As students build arrays, they can then view the product in numbers and words, as well as see the written expression. As a Common Core progression state, the focus in third grade multiplication is equal groups and arrays. In array situations, the role of the factors do not differ. One factor tells the number of rows, while the other factor tells the number of columns. But rows and columns depend on the orientation of the array. If rotated 90 degrees, the rows become columns and the columns become rows. Regardless of the orientation, students could visualize 4 groups of 3 or 3 groups of 4. When building conceptual understanding, it is important to use a variety of models in the classroom. In this task, students roll 2 dice and build an array to match the numbers. After writing an equation, the students then turn their tray and switch the factors while still maintaining the same product. So what do your arrays show? What does this one show?
4 times 5.
What does this array show?
5 times 4.
Do they show the same amount?
Yes.
How do you know?
Because it doesn't matter how it looks like.
Doesn't matter which way it's turned?
Yeah, it's
Are they
still the same
same
amount.
The commutative property can also be applied in grouping situations. 4 groups of 3 show the same product as 3 groups of 4. The product stays the same even when the objects are grouped differently. Regardless of whether we have 6 groups of 5 or 5 groups of 6, we still have the same number of dots.
They show the same amount.
How do you know?
Because this group has 6 and there are 5 of them, and there's 6 of them, but there are 5 of them.
So what multiplication equation could you go with the red dice?
6 times 5.
And what about,
5 times 6.
so how many do you have in each group?
I have 3 times 4 equals 12. And then I have 4 times 3 equals 12.
So do you have the same amount?
Yes.
The commutative property can also be shown by modeling equal groups on a number line. Can you use this number line to show me 3 times 7?
Yes.
Okay. So there's 1 hop of 7, 2 hops of 7, and 3 hops of 7. What does 3 times 7 equal?
21.
Okay. Can we turn that problem and hop 7 hops of 3 and still get the same answer?
Mm-hmm.
Show me. 3, 6, 9, 12, 15, 18, and 21. Is that 7 hops of 3?
Yes.
As students become flexible thinkers and recognize patterns on a multiplication chart, they soon see that learning the multiplication facts is not as daunting. If you know half of the multiplication chart, you automatically know the other half due to the commutative property. The next property of multiplication addressed by the standard is the associative property. The associative property states no matter how the numbers are grouped, the product will remain the same. If a baker has 18 cupcakes, he could package them into 2 boxes that each contain 3 rows of 3. 3 groups of 3 2 times equals 18. The baker could also package the cupcakes into 3 boxes. 3 groups of 2 3 times also equals 18. What does your array show?
4 times 4.
Okay, can you write that equation?
Yes.
4 times 4 equals what?
16.
Yes, 4 times 4 equals 16. We have 4 groups of 4. What if the cars, instead of parking in one parking lot, parked in 2 separate parking lots?
That would be 2 times 4 times 2.
Okay, can you write that down? We have 2 times 4 times 2. Do we still have 16?
Yes.
How could you solve this problem when you have 3 different numbers
Put
to
lines
multiply?
right here and here,
So we can group them?
and that would just be,
So you can multiply 2 times 4.
that would only be 8, and then 8 times, and then 8 times 2 equals 16.
And you could put other line right there.
You could change it and group it a different way. That's
Yeah.
right. So
Then
can you
still
solve
have the
that
same
problem
answer.
by working it out? What is 2 times 4?
2 times 4 is 8. 2
Okay.
times 4 is 8.
Okay.
And if you do it one more time, that's going to be 16.
16. So you have
Since 8 plus 8
2
equals 16.
groups of
Of
4
4.
2 times. So we have 3 times 2 times 2 by showing 3 groups of 2 2 times. Can you show 3 times 2 times 2 a different way? As the video shows, the student decided to group 2 times 2 to show 3 groups of 4. His model shows that regardless of how the numbers are grouped, the product is still 12. In the upcoming videos, 2 students solve the same problem in different ways. One student rearranges the order of the numbers to use known facts, while the other skip counts by 5. Which use of the associative property made solving the problem easier? Explain how the associative property can help you better solve the problem 2 times 8 times 5.
I can rearrange it 2 times 5 times 8.
And why did you rearrange it?
So I can group 5 and 2 together, which equals 10. And it will be 10 times 8 equals 80.
Multiply that by the next. Okay, so what is 2 times 8?
16 because 8 plus 8 equals 16.
Okay. Well, do you know what 16 times 5 is?
No, I don't know.
How could you figure that out?
I think I can do it by 5.
Like counting by 5?
Yeah.
Okay.
To 16.
16 times?
Yeah.
Okay. 5, 10,
10,
15,
50,
20, 25,
30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 75, 80.
80. Is that 16 times?
Yes.
Because you
Good.
have
5, 10, 15, 16.
It is important that students understand how to apply the properties of operations so that when presented with complex problems, they can use what they know about the properties of multiplication to solve for the unknown. A common error students make is forgetting that the equal sign means the same as. Students often solve one side of the equation first and then plug that answer into the unknown quantity. It is also important to emphasize the operations being used. The associative property works because we are multiplying in all of the situations. The next component of 3OA5 is the distributive property. With the distributive property, students can decompose unknown facts into smaller known facts. For example, when multiplying 4 times 7, the 7 can be decomposed into 5 and 2. 4 times 5 equals 20, and 4 times 2 equals 8. 20 and 8 are partial products that can be added together to find the total product. 20 plus 8 equals 28. So how did you break down your array into smaller parts?
I work out what 6 times 5 plus
Okay, can you write that down?
Yeah.
So you have 6 times 5, and what's the other part?
Plus 6
Okay, can you count by 5s?
Yeah.
Okay, let's count by 5s.
5
Okay,
10 15 20 25 30.
So 6 times 5 is 30. Now let's count by 2s to get 6 times 2. 2, 4, 6, 8, 10, 12. So we have our two parts, 30 plus 12. And how many do you have in all? 42. How did you break apart 6 times 7?
I put 3 times 7 plus 3 times 7.
Okay, show me how you did that. Did you break apart the 6 into 3 and 3?
Yeah.
Mm-hmm. Do you know how to skip count by 3s?
Yeah.
Let's skip count by 3s to see what 3 times 7 is.
3, 6, 9, 12, 15,
18,
21.
Okay, so 3 times 7 is 21.
Plus 21.
Yes, so what is 21 plus 21?
42.
42. So 6 times 7 is 42. So Jim knows 5 times 4 but doesn't know 5 times 6. How could Jim use 5 times 4 to find 5 times 6?
Well, we can do 5 times 6 and decompose or break apart 6 into 4 and 2. And we can do 5 times 4 plus 5 times 2. And this equals 20. 5 times 2 equals 10. And 20 plus 10 equals 30.
The basic understanding of decomposing unknown facts into known facts can support students in solving a variety of advanced problems with larger numbers. So how are you solving 5 times 15?
I'm gonna cut the paper to make it easier for me, and I'll put it.
So what number did you break apart?
I broke apart 15, but this is 10 and this is 5.
Okay, so what is your new array here?
This is 5 times 10,
And what is this array?
and this is 5 times 5.
Okay. Do you know what 5 times 10 equals?
50.
Okay.
So you put 5 times 10, and this is 50, and then you do 5 times 5, which this equals 25.
So those are your two parts, and then what do you do to those two parts to get your
then
final
we
answer?
add these two up, which it makes it 75.
Below this video, you will find a resource that shares 3 important steps to helping students master their multiplication facts. Phase 1 involves modeling and counting to find the answer. Phase 2 focuses on deriving answers using reasoning strategies based on known facts, which leads to Stage 3, when students reach mastery in automaticity. Automaticity, which is the focus of 3 OA7, is a result of rich work with the multiple standards in 3rd grade, especially 3 OA5. When exploring Unit 2 in the Georgia frameworks, you will find a variety of tasks that support 3 OA5.